we're going to take a look at conducting the Pearson's R correlational analysis of our data. To begin with, we're going to be able to select the statistics that we want to display and select the graphs we want to show. We'll take a look at the normality of our variables to make sure that's appropriate to use Pearson's R. We'll graph the correlation called the scatter plot to again make sure that Pearson's R is the appropriate way to analyze the data. The relationship should be linear, definitely not curvilinear. And we will select our correlation coefficient, that is, so we go with Pearson's R or Spearman's rho. And finally, we'll consider how we'd wrap the results APA style. So first, defining our variables and entering the data. We would want to go into variable view, type in the names of our variables, happiness and stress, indicate the measures, so that they're both scale variables. Then we can go into data view and record all of our data. Next, we're going to go ahead and graph and evaluate our variables here. If the scale of measurement is scale, that works for Pearson's R. Spearman's rho is even more flexible. They both have to at least just be ordinal. If both variables are normally distributed, that's a requirement for Pearson's R. Spearman's rho, a little bit more flexible. There are no outliers for Pearson's R. It's required. For Spearman's rho, a little bit more flexibility. So as you can see, Pearson's R is a lot more heavy on the requirements and presumably has a little bit more precision in letting you know whether you can reject a null or not. Spearman's rho is a little bit more relaxed, but it might be a little bit more difficult to know that you can reject the null. To do our analysis, we're going to click on the Analyze drop-down menu, and this is a look at the descriptive statistics. We're going to choose the Explore option, and we'll move into the dependent list our two variables. We're going to make sure that we get to see the histograms, and click Continue, and we're good. Click OK. Now we're going to evaluate our descriptive statistics and histograms to make sure that Pearson's R is the right correlational analysis to use. So for the happiness variable, the mean and the median is 5 for both. That's very consistent with it being normally distributed. Skewness is 0. When we look at the histogram, we can kind of see a little bit of it peeking in the background there. It looks fine. For our variable of stress, the mean is 6.0588 and the median is 6.000. So that's looking again pretty good, that they're similar, what we would expect for a normal distribution. And the skewness is really small. Basically, if we round it to a tenths place, it'd be negative 0.1, so small. And the histogram is also looking fairly normal from behind this label here. Okay, so Pearson's R is looking good for those two variables. We should also take a look at the scatter plot to make sure that the relationship is linear and definitely not curvilinear. So we'll go to Graphs, Chart Builder, click OK. We're going to choose the scatter dot. Here's our scatter plot icon. We'll choose our variables. So stress is going on the x-axis. That's what usually is used to make the prediction. And then happiness on the y-axis. That would then be our criterion. And on the axis for happiness here, we're indicating that we want to specify a custom tick size of 3. So we click OK. So here is our scatter plot. And because there's not a lot of options to choose, this is like a 5-point scale for both happiness and stress. It looks like there's a dot pretty much on everything. So we would use Pearson's R or Spearman's rho as long as the data looks either linear or just looks like a cloud of dots. But if it looks curvilinear, like a rainbow or a smile, then no, that would not be appropriate because it would violate the expectation that it's a linear relationship. And if you have this curvilinear relationship, it's clearly related, but you could get a correlation of like 0, saying that there's no relationship. So it would be misleading to do a correlation when your scatter plot is curvilinear. All right, let's go ahead and put in a best fitting line to fit this. So we go ahead and double click to open up that scatter plot, make it a little bit bigger, and we choose the elements drop down menu, fit line at total, and we can uncheck attach label to line, click apply and close, and now we have a best fitting line that goes through our scatter plot. Now in terms of doing the analysis, so we click the Analyze drop-down menu, then we click Correlate, Bivariate, bi meaning two, like bicycle, two wheels. We'll move our two variables over, and not only will we have Pearson's, but we'll just choose Spearman's to get an idea of the comparison there. Click OK. So here's our output for Pearson's R. The correlation is a negative 0.529, so it's a moderate negative correlation. And for Spearman's rho, it's really close, a negative 0.532. So we'll go with that negative 0.529 from the Pearson's R. And this correlation is statistically significant. So if we look at the significance two-tail right below, it's 0.029, and that's below our alpha level of 0.05. Okay, in terms of writing up our results. So we have written here a moderate negative correlation between happiness, and then open and close parentheses, and stress, open and close parentheses, was observed among the 17 behavioral statistics students surveyed in spring 2023, comma, the correlation is negative 0.53. So we brought the correlation into our write-up. Now we'll go ahead and grab the mean and standard deviation from our descriptive statistics, and we put that into our write-up. So for stress, open parentheses, and uppercase italicized M is equal to 6.06, comma, and then now current APA standards, it's a uppercase S here, or SD, is equal to 0.75 as a standard deviation. For happiness, the mean is 5, and the standard deviation is 0.79, and so that is used in our write-up as well. And then we bring in our significance test. So we indicate that the p-value was less than 0.05. We don't need to say that p-value was 0.029, because really what people are interested in is, should we retain or reject the null? If p is less than or equal to 0.05, you're telling the reader, we rejected the null. If you say p is bigger than 0.05, then you're telling the reader, we retain the null. And then our degrees of freedom for a correlation is our sample size minus 2, because you have two means, in this case a mean for happiness and a mean for stress. And both of those means get subtracted from our overall sample size of 17. So 17 minus 2 gets us 15. Okay, so we have our happiness information there as mentioned, and it looks good for our write-up. Here's our scatter plot with that best fitting line and the completed write-up. And that's how we do a inferential Pearson's R statistical test.